Hello. In this video, we'll discuss the chain rule. Let's write the heading down. The chain rule. So first, we'll start by discussing the definition of the chain rule. Definition. Okay. If you have a function f of x, if you have a function f of x and x is a function of another variable t, then we have the following. Then the derivative of the function f of x with respect to the variable t is equal to the derivative of the function f of x with respect to the variable x multiplied by the derivative of x with respect to t. So that is basically the definition of the chain rule. If you have a function f of x and x is a function of another variable t, then the derivative of the function f of x with respect to t is equal to the derivative of f of x with respect to x multiplied by the derivative of x with respect to t. So how do you apply this definition of the chain rule to a practical situation? So let's look at some examples and see how we apply the definition of the chain rule. Okay, so in each of these examples, we have to calculate dy dx. Okay, so calculate dy dx for the following. Calculate dy dx for the following. Number one, y is equal to cos of 2x squared. Number two, y is equal to sine of a cube plus x cube. Number three, y is equal to 10 to the power of 1 minus x squared. Okay, so let's look at the solutions of these examples, starting with number one. Solutions. Starting with number one. So we have to calculate dy dx. And for number one, y is equal to cos 2x. So y is cos of 2x squared. Okay, so let's go ahead and calculate dy dx for this case. So this implies that dy dx is equal to the derivative of cos 2x squared with respect to x. So in this case, we have to let u be equal to 2x squared. The reason why we let u be equal to 2x squared is because we have to simplify the expression and therefore make it easier for us to use the chain rule. So when we let u be equal to 2x squared, we then have the following implication. This implies that the derivative of cos of 2x squared with respect to x is equal to the derivative of cos u with respect to x. So now applying the chain rule, that is equal to the derivative of cos u with respect to u multiplied by the derivative of u with respect to x. So that's the chain rule. That's what the chain rule says. The derivative of cos u with respect to x is equal to the derivative of cos u with respect to u multiplied by the derivative of u with respect to x, because we're differentiating a composite function, which is cos of 2x squared. You have a cos function, and inside the domain of the cos function, you've got 2x squared, which is another function. So you're basically differentiating a composite function. All right? So now, this is how we apply the chain rule for this case. So let's go ahead and continue with the calculation. So we have to then work out the derivative of cos of u with respect to u. And the derivative of cos u with respect to u is minus sine u. So this is equal to minus sine u. And we have to multiply this by the derivative of u with respect to x. And u, as we noted here, u is equal to 2x squared. So we substitute u by 2x squared. And then we differentiate 2x squared with respect to x. The derivative of 2x squared with respect to x is 4x. So then we get minus 4x multiplied by sine u. But then, because this is the answer, we can then replace the u. In place of u, we can go ahead and put 2x squared, because we have to write our answer in terms of x. So then this is the final answer for example 1. It's minus 4x multiplied by sine of 2x squared. So this is how you would apply the chain rule for number 1. So let's look at the next one. Let's look at number 2. So for number 2, we have y is equal to sine of a cubed plus x cubed. So in this case, that implies that dy dx is equal to the derivative of sine of a cubed plus x cubed with respect to x. So again, we have another composite function, which is sine of a cubed plus x cubed. In this case, you have sine function, and inside the domain of the sine function, you have another function, which is a function of x, which is a cubed plus x cubed. So in this case, we have to let u be equal to a cubed plus x cubed. So we let u be equal to a cubed plus x cubed. So therefore, that implies that dy dx is equal to the derivative of sine, and we put u in place of a cubed plus x cubed because we said let u be equal to a cubed plus x cubed. So dy dx then is equal to the derivative of sine u with respect to x. And applying the chain rule to this gives us the derivative of sine u with respect to u multiplied by the derivative of u with respect to x. That's what the chain rule says. So let's go ahead and calculate this. The derivative of sine u with respect to u is simply cos u. So we multiply this by the derivative of u with respect to x. And u is, of course, a cubed plus x cubed. And we differentiate u, of course, with respect to x. And this is equal to the following. So the derivative of a cubed plus x cubed, you can go ahead and apply the sum rule for differentiation. Differentiate a cubed, which will give you 0, plus the derivative of x cubed, which gives you 3x squared. So then your answer then is 3x squared multiplied by cos u. And since this is the answer, we're going to put, in place of u, we're going to go ahead and put the a cubed plus x cubed, because this is the final answer, and we have to leave the final answer in terms of x. So that's our final answer. 3x squared multiplied by cos of a cubed plus x cubed. So this is how you apply the chain rule for this case. So that's the answer for example 2. And now let's move on to example 3, which is the last example. And in example 3, we are given y is equal to 10 to the power of 1 minus x squared. So in this case, we have dy dx is equal to the derivative of 10 to the power of 1 minus x squared with respect to x. So in this case, again, we have a composite function because the chain rule is applied when differentiating composite functions. We have 10 to the power of 1 minus x squared. That's our function. So this is an exponential function, a general exponential function with a base 10. So in this case, in the domain of the general exponential function with a base 10, we have the function 1 minus x squared. So we let u be equal to 1 minus x squared. And in that case, that implies that dy dx is equal to the derivative of 10 to the power of u. So in place of 1 minus x squared, we put u. We differentiate 10 to the power u with respect to x. And then we apply the chain rule. When we apply the chain rule to this situation, this gives us the following. We get the derivative of tan u with respect to u. We multiply this by the derivative of u with respect to x. So first we calculate the derivative of tan u with respect to u. The derivative of tan u with respect to u is given by 10 to the power of u multiplied by ln 10. Then we have to multiply this by the derivative of u with respect to x. In place of x, we put 1 minus x squared. In place of u, we put 1 minus x squared. Not in place of x, in place of u, because u is equal to 1 minus x squared. So we differentiate that then with respect to x. Now the derivative of 1 minus x squared is equal to minus 2x, because you differentiate the 1 and you get 0, minus the derivative of x squared with respect to x, which gives you 2x. So your answer is minus 2x. So in this case, the final answer then is the following. It's minus 2x multiplied by tan u. Okay. In place of u, because this is the final answer, we go ahead and put 1 minus x squared. Multiply this by ln 10. And this is the final answer for this example. Okay. So that's all the examples we have in this video. And we solved all the examples. So therefore, we have finished what we had to do.